Dr. M.C. Sundaraja. He completed his undergraduate studies from Madurai Kamaraj University and went on to complete his master's in structural engineering from the same. He is a doctorate from Anna University and he's also done his postdoctoral fellowship at the Queensland University of Technology, Australia. He has more than 17 years of experience in the teaching profession and he has also published papers in 39 international journals, 7 national journals, 27 international conferences and 51 national conferences. He has so far published 124 papers in various journals. He went on to receive the Best Research Paper Award from IFERP, a unit of VVERT and NIRE on 4th April 2015. He has also received Outstanding Faculty Award from the Venus International Foundation Faculty Award, VIFFA, in the year 2015. Currently, Dr. M.C. Sundaraja is now working as an assistant professor in Tyagarajar College of Engineering, Madurai.
Welcome to UGC lecture series on B-architecture. In the previous lecture, we have seen the design of beams under flexure by using working stress method and limit state method. We have seen both rectangular as well as flanged section by working stress and the limit state method in detail. In addition to this, we have also seen the design of continuous beam. Now, in this lecture, we are going to see the limit state design of the slabs. In this lecture, we are going to see the behavior of one-way and two-way slabs under the heads of classification of slabs, behavior of one-way slab and behavior of two-way slabs and differences between one-way and two-way slab. Before designing slabs, what are the classification of slabs in the field? The slabs are classified based on many aspects. First one is based on shape. The slab may be square, the slab may be rectangular or the slab may be circular and it may be a polygonal in any shape. That is, this is the square slab which is supported on 4 walls. So, here the Ly and Lx are same. That is, if you take Ly by Lx which is equal to 1, that is the square slab, and if it is supported on all 4 walls and the length of slab is different from length of or width of the slab, that is, here this is taken as Lx and this is taken as Ly. So, here Lx is divided by Ly is greater than 1, it has to be treated as rectangular slab normally, and it is also designed as, or it is also may be circular in shape, and the radius of the slab which is normally denoted by A or radius, or it may be in any polygonal shape. And based on the types of support, so the based on the shape, this may be classified into square, rectangular, circular and polygonal in any shape. Based on the type of support, the slab supported on walls, supported on beams and supported on columns. Normally, the slab which is supported on wall, which is normally called as a simply supported slab, or it is freely supported slab, and the slab which is supported on beam, maybe it is restrained slab which is having adequate provision to resist torsion at corners. If the slab is supported on walls, it does not have any adequate provision to resist torsion at corner. It needs to be in the slab needs to be designed for resisting corners or resisting the torsion which is developed due to the lifting up of corners in the slab. Next, the slab directly supported on column without any beams, that is called as flat slab. That is, the cross section of the flat slab is, these are all the columns, this is the slab which is directly supported on the column without any beam. These are all the slab which is called as a flat slab. The flat slab which is most suitable for certain circumstances, that is, the span of column is on both the directions are more and the height of roof is less. When the height of roof is less, if you provide or if you provide the slab over the column, that has to be provided directly. We cannot be directly provided on the column without any beam. It has to be directly first rest on the beam, and the beam has to be resting on the column by means of beam on both the direction. But in the case the flat slab which is designed or which is directly supported on column without any beam in any directions, it means that it does not have any beams on both the direction. So, in order to resist the moment as well as the shear forces over the support has to be enlarged to resist moment as well as the shear force at the support. Normally, the maximum bending moment which is developed at the support, that is a negative bending moment, and the moment which is developed in between the support is called the positive bending moment, which is somewhat less than the maximum bending moment, that is the negative bending moment over the support. In order to resist this maximum negative bending moment as well as the shear, the amount of concrete has been increased, that is the size of column has been increased. The increased or enlarged portion of this column is called as capital. This much amount of concrete which has to be used to resist this negative bending moment as well as the shear force, and near the middle of the span we got the slab portion, and near the end of the support again the thickness of the slab is gradually that is it is increased, thickness of the slab is increased. The increased portion of the slab here it is called as drop. This is a drop which is used to also resist the bending moment near the face of the support. And in similar manner here also we have the drop as well as the column head or capital. This type of slab is called as flat slab. It is directly resting on column without any beam. So, when the spacing between the column is more and also the height of roof is very less, in the second criteria, that is when the height of roof is very less, if we provide a beam we can't provide fan or any lighting arrangements or any ducts for providing AC. So, here in this such cases the beam has to be completely avoided and the slab has to be resting directly over the column. So, that type of slab is flat slab, and based on the support and boundary conditions, it is a simply supported slab. Another one is the cantilever slab, third one is overhanging slab, then it is fixed slab or it may be continuous slab. So, here simply supported slab, what do you mean by simply supported slab? The slab which is supported at its ends only, that is called as simply supported slab. Next one is cantilever slab. The slab, the one end of the slab is fixed and other end is free, it is called as cantilever slab. And another one is fixed slab. The slab which is fixed at both the end, it is called as fixed slab. And continuous slab, the slab which is continuous over the support or it has been supported on supports more than 2 supports, that is called as continuous slab. And overhanging slab, that is the slab is extended beyond the face of the support, the portion of the slab here it is called as overhanging portion, that is called as overhanging portion, and the portion between the support is called as simply supported portion. So, this type of slab is called as overhanging slab, which is extended beyond the supports. Now, next one, based on use it is a roof slab, floor slab, foundation slab, water tank slab. Normally, in the case of a building, this is the building which is having more than 2 floors. So, here these slabs are called as floor slabs. The intermediate slabs are called as floor slab, and the final, that is the floor slab which is the slab which is provided at the top, here it is called as roof slab. And the foundation slab which is normally happen in the case of design of the mat or raft foundation. When you connect all the columns by means of a single foundation, that is called as a mat foundation. In this class, all the column which is connected by means of a common slab, that is called as foundation slab. This has happened in the case of mat or raft foundation. Water tank slab, normally the slab in the case of elevated water tank, the water which is normally stored on the slab portion, that is called as water tank slab. And next one is based on the cross section or sectional configuration. It is ribbed slab, otherwise called as a grid slab. A grid slab means the slab which is supported over the beams which are closely spaced, that is called as a grid beams, or otherwise the slab which is supported on those grid beams is called as grid slab. And another one is a solid slab, it does not have any vacuum inside. That is, next one is a fillet slab and another one is folded plate. The folded plate slab which is normally provided in the case of portico portion, that is the portico portion which is also normally the portico slab is a flat which is projected from the beam from the building. So, it has to be normally it is uniform, the thickness of the slab is uniform, but it has to also be folded like a paper, that is a folding of papers. So, that is called as a folded plate slab. Next one is based on the spanning direction, this is most important thing. So, that these two things we are going to discuss in the subsequent lectures, that is one way slab, another one is two way slab. The slab spanning in one direction is called as one way slab. The slab spanning in two direction is called as a two way slab. So, in general the rectangular one way and two way slabs are very common and are discussed in detail in this lecture. One way slab, that is the slab which is spanned along only one directions, always it listen. So, here for example, then how to differentiate the one way slab and two way slab, under what circumstances the slab has to be designed. This is the building. Now, this is the slab has to be designed for the building. Now, here this is Ly and this is Lx. Lx is the length of portion along x direction, Ly is the length of portion along y direction. If you take this as 9 meter, if you take this as 3 meter. For 9 by 3, that is the ratio Ly by Lx, that is 9 by 3 which is 3, if it is greater than 2, the slab has to be designed as one way slab. It can be spanned along only one direction. That is, it means that in this type of slab, the slab is going to be spanned along shorter direction, that is 3 meter, that is along only one direction. Anyway, in the case of one way slab, Ly is much larger than Lx. In the case of one way slab, the slab has to be supported along shorter direction, that is along Lx direction. That is called as one way slab. The slab is supported or spanned along only one direction. It means that it has to be resting on the wall on two opposite sides. It can also be supported on this side, but it has to be designed as one way slab. It has to be spanned along only one direction, that is along shorter direction, that is along 3 meter direction. The reinforcement has to be also be provided along only one direction, that is the main reinforcement has to be provided along only one direction. In the case of one way slab, when you take the cross section of the slab, this is the cross section of the slab. Now, it is these are all the support. So, I have already told you that simply supported slab, the slab which is supported at its. Now, it is subjected to some kind of forces. What will happen? This is the deflection of the slab. When it deflects like this, so in this this slab is going to be also resting on this portion, this walls, that is this walls and this wall. There is also a deflection on this along this direction, but here the deflection along longer direction is very small when compared to the deflection along shorter direction. Hence, the deflection along longer direction is completely neglected, it is almost negligible when compared to the deflection along shorter direction. That is why the slab has to be spanned along only one direction, that is along shorter direction, that is the direction on which the bending is maximum. But in the case of two way slab, how the two way slab has to be supported. So, this is a room. So, here this is taken as Ly and this is taken as Lx. As per IS 456 2000, the ratio Ly by Lx is less than or equal to 2, the slab has to be designed as two way slab. It means that the slab has to be supported along both the direction on all 4 walls, understand. So, it means that there is a deflection along longer direction and also the deflection along shorter direction. The deflection along or the bending along both the direction has to be considered, and the bending moment has to be found along both the direction by taking the section along both the direction. For these two bending moment, we need to find out the respective, we need to find out the area of reinforcement. That reinforcement has to be provided in the respective direction. So, here the reinforcement has to be provided along both the direction. In this one, the reinforcement has to be provided along only one direction. Now, here in the case of one way slab, now how the slab has been behaved. Now, the one way slab supported by parallel walls or beams bend only one direction and transfers their loads to the two opposite support on the walls on the beams. So, here this is the slab which has been considered as a one way slab. It is supported on these two opposite beams or opposite walls, and the slab load has to be transferred to these two beams or two walls only. It will not be transferred to these two opposite beams in the other directions. That is called as one way slab. And even when a rectangular slab is supported, that is why I have talked about. In the case of rectangular slab also, even when the rectangular slab is supported on all the 4 edges, the slab may be considered as a one way slab if the length to width ratio of the slab is greater than 2. So, this is I have explained. If the Ly by Lx is greater than 2, this slab has to be designed as one way slab. That is, the bending along longer direction is very small when compared to bending along shorter direction. So, the bending along longer direction, it has to be completely neglected. So, it has to be supported along only one direction. A one way slab is designed for the spanning direction alone. The main reinforcement, the main tension reinforcing bars of such slabs run parallel to the span, that is parallel to the spanning of the slab. For the transverse direction, a minimum amount of shrinkage reinforcement is provided. That is, in the case of one way slab, the main reinforcement has to be provided along shorter direction, since it is spanned along the shorter direction. And in order to keep this main reinforcement with the proper spacing, there is a reinforcement which is provided in the perpendicular direction. This reinforcement is called as distribution reinforcement, and this reinforcement is called as main reinforcement. So, this distribution not only to distribute or keep the main reinforcement with the proper spacing, it is also to avoid the cracks due to shrinkage and creep of concrete in long term. So, that is this reinforcement is called as distribution reinforcement. It is not only to distribute or keep the main reinforcement with the proper spacing, it is also to avoid the cracks which is developed due to shrinkage and creep of concrete. Next, so in this case, the distribution reinforcement should be provided as a minimum reinforcement as per IS 456-2000. I will tell you later. Next, one way slab action is assumed in a ribbed slab, that is ribbed floor slab, the slab with joist beams made of precast double T sections in ribbed floor with integral beams and also in hollow block or core slab. So, this is in the case of the ribbed and beam, the slab which is having integral beams also. Now, that is all about the behavior of one way slab. The behavior of two way slab, this is I have already started. That is, two way slabs are the slabs that are supported on 4 sides, and the ratio of longer span to the shorter span is less than 2. That is, here Ly by Lx is less than or equal to 2. There is a bending along both the direction, it has to be considered for the design of the two way slab. So, it has to be supported along both the direction, the reinforcement has to be also spanned along both the direction. These two reinforcement are called as main reinforcement, but it is not like in the case of one way slab. In the case of one way slab, it is spanned along only one direction, but the reinforcement which is provided in the perpendicular direction is called the distribution reinforcement. It is not a main reinforcement, it is a minimum reinforcement. It is only to distribute or keep the main reinforcement with the proper spacing and also to avoid the cracks which is developed. in long term due to creep and shrinkage of concrete. In the two-way slab, this load will be carried in both the directions. So, in the case of one-way slab, the load has to be transferred along only one direction, that is on these two opposite beams or walls, not on these two walls, since it is spanned along only one direction. But in the case of two-way slab, if the slab is, since the slab is spanned along both the directions, and the slab is supported on both the direction and the main reinforcement is also provided along both the direction, the load has to be transferred along both the direction on opposite beams or both the directions. So, the load will be carried in both the directions. So, main reinforcement is provided in both directions for two-way slab. The plan view of one-way slab supported on two opposite edges are supported on all edges, that is L by B ratio, it is greater than 2. This is the behavior of one-way, that is I have already explained you. So, here when it is subjected to the load acting, so that bending which is along only one direction. So, the reinforcement has to be along which is provided along only one direction. So, this is the behavior of two-way slab. The slab when it is spanned along both the direction, the load has also been transferred to both the direction on the wall or beam on the x and y direction. So, if it is a rectangular slab, the transformation of this load is like this. So, here this is normally this line which has been based on the yield line theory of the slab, the crack which is normally developed on this direction, that is the first in the case of rectangular slab, the crack is developed from the corners, and here also it is developed from the corners, and this which is developed like this. This is the bending of the slab, the crack which is normally developed, which is normally seen in the case of yield line theory of slab. So, here this is the crack formation of the slab. So, it means that this portion or rectangular portion of the slab is going to be transferred on this beam, and this trapezoidal portion of the load from the trapezoidal portion of the slab is going to be transferred to this beam in similar manner on this beam and on this beam. This is the transformation of load in the case of rectangular slab if Ly by Lx is less than or equal to 2. If Ly by Lx is less than 2, it is perfectly a square slab, and the load transformation is like this. The slab is divided into 4 triangular portion, but here it is divided into 2 triangular portion and 2 trapezoidal portion based on yield line theory of the slab. So, here the load from one portion of this one quarter portion, that is one triangular portion, transferred to this beam and on this beam also. So, here this is the way of transformation of load on the rectangular as well as the square slab. This is again it is the behavior of one-way and two-way slab. The slab is the load is transferred to this beam and this beam. This is in the case of one-way slab, and here this is the slab which is considered as two-way slab. The slab is load from the slab is transferred to on this beam as well as on this beam. So, here now we have seen the behavior of the slab as well as how the reinforcement has to be provided, how the loads are transferred to the beam in both one-way and two-way slab. Now, we need to understand, we need to know what are the differences between one-way slab and two-way. We need to summarize. In the case of one-way slab is supported by beams in only two sides, that is since it is spanned along only one direction, it has to be the load must be transferred to the two opposite beams or two opposite walls. But in the case of two-way slab, the two-way slab is supported by means on 4 sides. If the slab is supported on all 4 walls or on all 4 beams, if Ly by Lx is less than or equal to 2, since the load is transferred to both the direction, the two-way slab is supported by the beams on all 4 sides. And based on the ratio of the longest span to the shortest span is greater than 2 in the case of one-way slab. So, when Ly by Lx is greater than 2, it has to be designed as one-way slab. It has to be spanned along only one direction and it has to be supported on 2 opposite walls only, that is all. Then the ratio of longest span to the shortest span is less than or equal to 2 that has to be designed as two-way slab. That is, I have already told you in detail. Now, the main reinforcement, how to provide the reinforcement in the case of one-way slab. The main reinforcement provided in only one direction for one-way slab, and the main reinforcement has to be provided in both the direction in two-way slab. In the case of one-way slab, the reinforcement which is provided in the perpendicular direction is called the distribution reinforcement, that is a minimum reinforcement that is not going to take any load. In the case of one-way slab, the reinforcement which is provided along shorter direction is going to take load, since that load is transferred on that direction to the opposite beams only. But in the case of two-way slab, since the reinforcement going to be, that is, since the load is transferred to both the direction, the reinforcement must be placed along both the direction. Okay. Now, these are all the differences between one-way and two-way slab. So, now we come to the summary of this lecture. In this lecture, we have seen very detailed about the behavior of one-way and two-way slab under the classification of slabs, and the behavior of one-way slab and two-way slab, and the differences between one-way and two-way slab. So, here we must, before designing these two slabs, we must understand how it behaves, how the reinforcement has to be provided, that is most important. So, before designing these two slabs. Regarding this portion, the questions are: explain the classification of slab. So, we need to explain the classification based on various categories, based on the shape, based on the supporting condition, based on the spanning condition, based on the reinforcement has to be provided, based on the slenderness, that is Ly by Lx ratio. We can divide the slabs into many categories. Next, differentiate between one-way and two-way slab. Now, explain the behavior of one-way slab with needs gauge, and explain the behavior of two-way slab with needs gauge. Explain the differences between one-way and two-way slabs. So, in the case of these questions, so we must know the differences between one-way and two-way slab in detail. That is, in connection with this, the references are IS 456-2000 plain and reinforced concrete code of practice. Now, here in this lecture, that is in the unit of slabs, we are going to follow completely IS codal provisions for the design of slabs, that is both simply supported slab and restrained slab, as well as in the continuous slabs. Next, IS 875-1987, the code of practice for the design load other than earthquake for buildings and structures. So, here in the case of in our places, we need to consider only the vertical load for the design of slab. We can also consider the earthquake forces, but here we are going to consider only the vertical forces, that is dead load and live load. We are not going to consider any snow load or earthquake forces. Next, important code book is ESP 34/1987, that is a handbook of concrete reinforcement and detailing. So, this handbook is most important. This gives enormous amount of detail about the design of reinforcement in the case of concrete structures. All the members starts from the slabs, beams, columns, footings, in all places. With regard to the books, that is a reinforced concrete design, which is written by S.N. Sinha, which is published by Dr. McGraw-Hill Publishing Company Limited, New Delhi. The edition is 99. Now, the recent edition will also be going to be published. Next, one book is written by Ashok K. Jain, that is Reinforced Concrete Limit State Design, which is published by Nemchan and Brothers. So, it is from Roorkee. The published year is 2006. Thank you very much.